Hello students, today we begin our organic chemistry chapter. This is one of the most important areas of chemistry because carbon forms the basis of fuels, medicines, plastics, food, and even life itself. Let us start step by step. Organic chemistry is the study of carbon compounds. Carbon is a unique element because of two main reasons. First, it shows tetravalency. It can form four covalent bonds. Second, it shows catenation. It can link with itself repeatedly to form long chains and rings. These two properties allow carbon to form millions of stable compounds, which is why organic chemistry is so vast.
Ma'am, do other elements also show catenation?
Yes, elements like silicon and sulfur can show it, but not as strongly as carbon. Carbon-carbon bonds are the strongest and most stable. That is why carbon compounds dominate. Carbon is special because it forms strong covalent bonds. It bonds easily with elements like hydrogen, oxygen, nitrogen, and halogens. It forms resonance-stabilized structures which are very stable. That's why we find carbon compounds everywhere in fuels, fibers, medicines, and food. Organic compounds can be classified into alkenes, single bonds only, saturated hydrocarbons. Alkenes contain double bonds, unsaturated. Alkynes contain triple bonds, unsaturated. Aromatic compounds like benzene, which are stabilized by resonance. Another way to classify compounds is by functional groups. These are specific groups of atoms that give compounds their chemical properties. Some important ones are alcohols with OH, aldehydes with CH,O ketones with CO, carboxylic acids with COOH, amines with NH2, esters with COOR.
Ma'am, is functional group more important than the chain length?
Good doubt. Yes, functional groups decide the chemical properties, while the chain length usually affects the physical properties like boiling point or solubility. Now, let's learn how to name compounds. We use IUPAC rules. Select the longest chain of carbon atoms. Number the chain from the side nearest to the functional group. Use prefixes for substituents and suffixes for functional groups. Let's take examples. CH3-CH2-OH is named as ethanol. CH3-COOH is named as ethanoic acid. CH3-CHO is named as ethanol. So you see, the suffix changes depending on the functional group. Next, let's talk about isomerism. Isomers are compounds with the same molecular formula but different structures. For example, C4H10 can exist as normal butane, a straight chain, and as isobutane, a branched chain. Structural isomerism has three main types: chain isomerism, difference in branching; position isomerism, difference in position of double bond or substituent; functional group isomerism, different functional groups with same formula. Another type is stereoisomerism. Here, the connectivity of atoms is the same but the spatial arrangement differs. Examples: cis trans isomerism in alkenes, optical isomerism in compounds with a chiral carbon atom. Now some fundamental concepts. In methane, carbon is sp3 hybridized, forming a tetrahedral shape. In ethene, it is sp2 hybridized, forming a planar shape. In ethine, it is sp hybridized, forming a linear molecule. Resonance is the delocalization of electrons within a molecule. The best example is benzene, where electrons are spread evenly, making all C-C bonds equal. The inductive effect is the shift of sigma electrons in a carbon chain due to differences in electronegativity. This effect influences reactivity of molecules. Hyperconjugation is the delocalization of electrons from C-H bonds to a nearby carbocation or double bond. It stabilizes carbocations and alkenes. Now, hydrocarbons. Alkenes are saturated hydrocarbons. They are not very reactive, but they show substitution. For example, methane reacts with chlorine in sunlight to form chloromethane and hydrogen chloride.
Ma'am, can this reaction stop after one substitution?
Not easily. The reaction continues and can form dichloromethane, chloroform, and even carbon tetrachloride. Alkenes are unsaturated hydrocarbons. They show addition reactions. Examples: ethene plus hydrogen in presence of nickel catalyst gives ethane. Ethene plus bromine gives dibromothane. The reddish-brown color of bromine water disappears, which is a test for unsaturation. Ethene plus water in presence of an acid catalyst gives ethanol. Remember, bromine water test distinguishes alkenes and alkynes from benzene. Alkenes decolorize bromine water, but benzene does not because of resonance stability. Alkynes contain triple bonds. Ethyne plus hydrogen gives ethene, and on further hydrogenation gives ethane. Ethyne reacts with sodium metal to give sodium acetylide and hydrogen gas. This shows that alkynes are weakly acidic. So students, today we covered the basics of organic chemistry, why carbon is unique, how compounds are classified, UPAC naming, isomerism, hybridization, resonance, and reactions of alkanes, alkenes, and alkynes. In the next session, we will study aromatic compounds and functional group chemistry. That's all for today. Jai Hind.